So in this video, what we want to do is to understand where the following three rules for powers come from, to look at a couple of special cases, that x to the power of 1 is x and x to the naught is 1, and also to understand and interpret what negative and fractional powers mean. So let's go on to a new slide and see where the first of these rules for powers comes from. So I've written out here what x to the power of p means. It means x multiplied by itself p times. So x to the power of 2 means x squared, x multiplied by itself. And if we look now at the product x to the a multiplied by x to the b, what that means is x times x times x dot 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 times x a times, so this is x to the a, multiplied now by x to the b, so again we multiply this by x times x times x, etc. times x, b times, so we are multiplying in effect x by itself a times and then another b times. So we are multiplying x by itself, x times x times x times x, a plus b times, and this, based upon our definition of what x to the p means, is x to the a plus b. So x to the a times x to the b is x to the a plus b, and that is the first of the three rules for powers. So let's move on to the next slide and show the second of our three rules for powers. So what we now want to consider is x to the a divided by x to the b. So this means x times x times x, etc. multiplied by x, a times in the numerator, and in the denominator we have x times x times x times x, b times in the denominator. And what we can now do is we can cancel some of these x's. So we can cancel the first one with this here, we could cancel the second with this here, etc. And what you can see is that we are going eventually to delete b of the powers of x in the numerator. So we are going to be left in the numerator, assuming that a is greater than b, we are going to be left with x times x times x, a minus b times. So this, again using our definition of the notation, is x to the a minus b. So this is the second rule for powers. X to the a over x to the b is x to the a minus b. So let's just show a quick example of this. Supposing we had x to the 5 and we were going to divide it by x cubed, we would have x times x times x times x times x divided by x times x times x. That's what x to the 5 means, that's what x to the power of 3 means. And then we could cancel that with that, this with this, this with this. We're left in the denominator with 1. In the numerator we are left with 2 powers of x, and that is therefore x squared. And rather than writing these things out and cancelling them explicitly, it is dramatically easier to use the rules for powers and just to subtract the 3 from the 5 and to be left with x squared. So this is the second of our rules. Let's move on to the next slide and look at the next rule. So the next rule that I want to look at is x to the power of a all to the b. And what this means is x to the a multiplied by x to the a multiplied by x to the a, etc., b times. So what we have here is we have x multiplied by itself a times, and then another a times, so that's x to the 2a, and then if we had a third time it would be another x to the a, so we'd have x to the 3a, etc., and we have it b times, so we have in total x to the a times b. So let's just do an example of this for clarity. Let's look at x squared and let us cube it. This means x squared times x squared times x squared. And we could either expand that out and just realize that what we have here is x times x times x times x times x times x, so there are 6 powers of x, or we could use our previous rule and say we add this to this, which gives us x to the 4, and then we could add that to it, which would give us x to the 6. So either way we will get the result of x to the 6, which is 2 times 3. So this is our other rule, that x to the a all to the b is x to the a times b. Now at this stage we notice also the fact that a times b is the same as b times a, so we should perhaps at this stage note the following: a times b is equal to b times a, so therefore x to the a all to the power of b is the same as x to the b all to the power of a, which is x to the a b. So x to the a raised to the power of b is the same as x to the b raised to the power of a, and it's x to the a times b. In terms of our example here, what this is saying is that x cubed squared is the same as x squared cubed. X cubed squared is also x to the 6th. So what we've done up to now in the video is we've rather rapidly shown all 3 of the essential rules for powers. And these are the only rules for powers, and apart from this it is a matter of special cases and interpretation. So what I want to do on the next slide is to look at 2 special cases. So the special cases that we now want to discuss are that x to the power of 1 means x and x to the power of 0 means 1. So let's see where these 2 special cases come from. Well, from our previous rules, I could say, for example, that x to the power of 5 divided by x to the power of 4 is x to the 5 minus 4, which is x to the 1. But x to the 5 divided by x to the 4, if we were to perhaps spell it out, means x times x times x times x times x, x to the 5, divided by x times x times x times x, that's x to the 4. And again, we can cancel some of these, this with this, this with this, this with this, this with this. We're left with a 1 in the denominator, and we see that we're left overall with x divided by 1, so the right hand side here is just equal to x. So that means that we have seen that x to the power of 1 is x, and that is the first of our special cases. And we notice that there's been nothing special about x, so this means that, for example, 2 to the power of 1 is 2, 7 to the power of 1 is 7, etc. The other special case that we want to look at is x to the power of 0. So let's consider that now. Well, let's look at x cubed divided by x cubed. This is clearly just 1 because we have the same thing in the numerator and the denominator, and if you divide something by itself you will get 1 as long as the thing on the bottom is not 0, which we should not be doing. But from our rules for powers, what we have here is x to the 3 minus 3, which is x to the 0. So therefore we see that x to the 0 is equal to 1. So, for example, this means that 2 to the 0 is 1, and 107 to the 0 is also 1. So these are the two special cases that we need to understand. Something raised to the power of 1 is itself, something raised to the power of 0 is 1. So, having seen where the three rules come from, and the two special cases of something raised to the power of 1 and something raised to the power of 0, what I want to do now is I want to move on and to look at the interpretation of negative and fractional powers. So I now want to consider what negative powers mean, for example something like 7 to the power of minus 2. Now we can understand what negative powers means in different ways. For example, supposing I was to write out x to the power of 2 and divide it by x to the power of 4. If I was to spell this out, I would say I have x times x divided by x times x times x times x. And again, I could cancel this x with this x with this x. I'm left in the numerator with a 1, and I have 1 divided by 2 powers of x, so this is equal to 1 over x squared. But from our rules for powers, we also know how to write this out. We can write this as x to the 2 minus the power in the denominator, so it's 2 minus 4, so this is x to the 2 minus 4, so this is x to the minus 2. So generally we have that x to the minus a means 1 divided by x a times. So concretely, for our example, at the top here, 7 to the minus 2, 7 to the minus 2 just means 1 divided by 7 squared. So it's 1 over 49. So all a negative power means is that you are dividing by this number here, or the x to the power of the positive number. So x to the minus 3, you're dividing by x 3 times. So that's what negative powers mean. What about fractional powers? We'll move on to another slide to see that. So what we now want to do is to understand what fractional powers mean, for example what it means to write 4 to the power of a half. Well, supposing we look at x to the power of 1 over a. And let's raise this to the power a. Then from one of our previous rules we know that we can write this as x to the 1 over a multiplied by a, and that means it is x to the 1, and we've convinced ourselves already that x to the 1 means x. So this tells us that x to the 1 over a multiplied by itself a times gives you x, and we call that the 8th root of x. So therefore x to the 1 over a is the 8th root of x. So for example, 4 to the half is going to be the square root of 4, and that is 2. Or for another example, let's consider 27 to the 1/3, and that is going to be the cube root of 27, and that is 3, because 3 cubed is 27. So we now have an understanding of what fractional powers mean. We can now combine the last two slides to look at what perhaps negative fractional powers mean. So let's do that. So if we say that we want to understand what x to the minus 1 over a means, we can realize first of all that the negative sign here just means that we are dividing by x to the 1 over a. That's all, remember, that a negative sign in a power means. And we have said that x to the 1 over a is the 8th root of x, so that is all that means. So, for example, if we were to look at something like 100 to the minus a half, that means 1 divided by 100 to the half, which is the square root of 100, and the square root of 100 is 10, so that is 1 over 10. And that is all that negative fractional powers mean. So another example would be, what is 81 to the minus a half? And that is 1 over the square root of 81, and the square root of 81 is 9, so that is 1 over 9. And another example would be, what is 1,000 to the minus 1/3, and that is going to be 1 over 1,000 to the 1/3, and that is 1 over 10, because 10 cubed is 1,000. The cube root of 1,000 is 10. So we've understood what positive and negative fractional powers mean, but up to now all the examples I've used of fractional powers have had a 1 in the numerator, so I now want to look at a couple of examples where the number or the quantity in the numerator of a fractional power is not 1, and to do that we'll go on to a new slide. So let's consider here x to the power of a over b. And we can write this as x to the a all to the 1 over b, and then we recognize that this is the bth root of x to the a, or equivalently we could write this as x to the 1 over b all to the power of a, because a times 1 over b is the same as 1 over b multiplied by a. So this way of writing it means that it is the bth root of x all to the power of a. So these are two different ways of writing x to the a over b. So, for example, if I was to say what is 8 to the 2/3, I could write that as 8 squared to the power of 1/3, which is the cube root of 64, which is perhaps not immediately obvious. Or I could say that this is 8 to the 1/3 squared, and 8 to the 1/3 squared is 2 squared, and 2 squared is 4, which is of course the cube root of 64 as well. So we can use these methods of writing out general fractional powers and write out what 8 to the 2/3 is and understand other quantities in that way. Negative general fractional powers, of course, just mean 1 over the fractional power, so I'll write that on a new slide. So a negative general fractional power like x to the minus a over b, we realize again the minus sign simply means that we have 1 divided by x to the a over b. And this then means again, just as before, that we could say that this is 1 divided by the bth root of x to the a, or we could say that this is 1 divided by the bth root of x, all raised to the power of a. So that is all that a negative general fractional power means. And something else that I would like to emphasize, which I think is very important to be confident with, is that if you have a fraction, let me call this, for example, p over q, and that this is raised to a power, let's say a, that this means p over q multiplied by p over q, etc., multiplied by p over q, a times, but here we see in the numerator we have p times p times p, a times, so we could say that this is p to the power of a, and in the denominator we have q, a times, so we can write this as q to the a. So a fraction raised to the power a is the same as the numerator raised to the power and the denominator raised to the power. So on the final slide, I'm just going to give a couple of examples and then we will stop the video. So on this final slide, I've got two examples. The first one is what is 100 to the power of minus 3 over 2. Well, the minus sign just means that we have 1 divided by 100 to the 3 over 2. And this can be written as 1 over 100 to the half, all cubed. 100 to the half is the square root of 100, and that is 1 over 10. So we have 1 over 10 cubed, and 1 over 10 cubed is 1 over 1,000. So 100 to the power of minus 3 over 2 is 1 over 1,000, a thousandth. Similarly, if we have 4 over 9 to the power of 3 halves, because this is a fraction, we can write this immediately as 4 to the 3 halves over 9 to the 3 halves. 4 to the 3 halves is 4 to the half cubed. 9 to the 3 halves is 9 to the half cubed. 4 to the half means the square root of 4, that is 2. So we have 2 cubed, divided by 9 to the half, the square root of 9, it's 3. So we have on the bottom 3 cubed, because of the power 3 here. 2 cubed is 8, 3 cubed is 27. So we see that 4 over 9 to the power of 3 over 2 is 8 over 27. So in this video we have seen the rules for powers, we've seen where they come from, we have seen what it means to have negative powers. It just means that you are dividing by whatever the quantity is to a positive power. And we've understood what fractional powers are, that they are the roots. So 4 to the half is the square root of 4, 4 to the 1/3 is the cube root of 4, etc. And we've understood how we can write 4 to the 3/2. Here we've written it as 4 to the half all cubed. If we'd wanted to, we could have written it as 4 cubed all to the power of a half, but that would not in this case have made the problem so easy, and we should, as mathematicians, be trying to look for the easiest root. So with that, I'll end the video.